We have Elena Glassman in town. Very good to see you. I had to run over here, so catching my breath. So Elena is a professor and assistant professor at Harvard, and we've known each other for quite a while, but we've never hosted it before. So Elena, the way we know each other is through various program committee meetings, MISC notably. And so Elena is working in the areas of programming and helping people program. So her specific bio, I'm not going to read it because I'm going to die. But this must be the best introduction you've ever heard.
This badge is my talk. It's breathy, it's excited, it's fresh.
Okay. So most recently, so I know a lot of your previous work. Your more recent work is focused on AI and how to integrate that into interface design and development. And I will just pass it over to you. Thank you for coming, Elena. There will be lots of meetings afterwards as well. This will be recorded and we can share it with you. And yeah, we're looking forward to your talk. And that's it, I think.
Awesome. Yeah, I'm grateful to be around in this field long enough to be like, I'm not exactly sure when we first met. It was a while ago, and it's like really nice to be here in person. I think the last time I was here was maybe like 5 or 6 years ago. But I've never been here as part of a joint kind of IS-CS gathering like this one. And so because you guys are such a unique community here in Michigan, like really beautiful commingling of computer science and IS, I thought that you could handle a really new talk that I am figuring out how to communicate. It's the stuff that I'm most excited about. So rather, you should treat this as, just interrupt me if something's not clear. I mean, obviously, I want to know what's confusing, what's not confusing. There are things here that to me are like deeply profound because I've been staring at them for a decade, and I say them in a sentence, and it doesn't evoke the same profundity in your mind because you've just seen it. And really that kind of curse of knowledge, or as Mark Style played out earlier, the reversal of expertise. I'm very excited to hear your reactions to these and your boundary pushing questions and challenges to how I am describing the 3 conditionally accepted Chi papers that I'm going to go over today. So, all right. The way that I'm currently thinking about interfaces and from an HCI perspective, especially those that are AI powered, is how I want to make people more resilient to the choices that AI make, that they're either objectively wrong, I mean, that everyone's concerned about that, but also subjectively inappropriate, or contextually inappropriate and subjectively not exactly what you want, right? So I have been, I'm going to try to ground this new work in a diagram that I've been iterating on for the last 2.5 years to organize my thoughts. Basically, every time I write a new paper or I find a new paper I really like, it inevitably means adding a detail to one of these arrows, right? And so just like high level, the details underneath each arrow as of, the Chi course that we taught last May, which will be hopefully updated soon because we're going to teach it again if anyone's interested, is on archive. It's just kind of like a handout that I gave. But basically it's like we're going to underpunch our weight if we're building a system that does not at least think about how we can support the forming, revision, or refining of intent. Sometimes we kind of assume someone's coming in and they already know what they want to do, right? But they could be wrong about it. It could be an evolving intent. They realize through interacting with the system that's not actually what they wanted. They may have not enough of a mental model to even formulate an intent, right? So that is a non-trivial reflection step. There's an expression of their intent that could be in different modalities. There's all sorts of fun things you can do there. Obviously, because I'm not an AI, this is kind of the box that I don't touch, but we can re-execute if it's machine code that's kind of, if the semantics are fully specified, or re-infer if it's a specification that's a little bit ambiguous, or regenerate if we're using generative AI, and we just give me more, right? And then there's this broad space of ways in which we can reflect back that re-execution, that re-inference, that regeneration back to the user. And I just want to point out, using the language from psychology, like Herbert Simon's Using Language, everyone should read it. It's a beautiful book. And he breaks down actually the communication, the subtle, every little step and cognitive step between two humans communicating. And basically this diagram is me just swapping out one of the humans for a computer and asking, is it different? The language of common ground I think is really helpful here, where everything that's reflected back and rendered in the interface becomes hopefully part of the common ground the system and the human can now share that can ground further clarifications or realizations, as long as the human, it's something could be in the interface, but they may not notice or really even be able to take it in. So just because it's here doesn't mean it's definitely in the common ground, but externalizing it in the interface enters it into the potential common ground between the humans. And then finally, this acknowledgement of people's private contexts, their values, their preferences, their risk tolerances. These I put inside the little human head because they are, for the most part, I think, private. They're difficult. They're not. You might eventually have so much surveillance data about people that you could say, oh, well, next year that won't be private anymore. I'm not trying to plan for that. I don't think that's a good outcome. We will always have experiences, priors. I taught this class last week, and now I'm looking at homework that was written by students who were in that class, right? That the system's not going to have. So I want to help people have meaningful autonomy to accept or recover from AI choices that are imperfectly guessing what's best. And I think that I think a lot of our interfaces are actually not designed for that particularly well. So I feel a little uncomfortable saying that, but how many people are aware of the human AI interaction work by Inertia et al. Out of Microsoft? It was kind of a 20-year follow-up to the MISC initiative paper, and they had a set of design guidelines. And so I feel a little nervous critiquing that paper because it's a terrific paper. It's great. And I'm just adding that, there are some, again, the same way that I'm trying to break out the details of each of these arrows, in order to know that you need to recover from a choice, in order to take advantage of an affordance, recover from an AI affordance that you think is not right or not right for you, you have to recognize, you have to notice that that choice was made, and then judge it well, that it is actually not right for you. And then you can take advantage of efficient dismissal, modification, or recovery, right? So that is kind of my reason for this talk, reason for almost realize a lot of the work that I have been doing. So, just so that you have a sense that this is not entirely new. I've been working on systems to help people form, revise, and refine their intent. A lot of these earlier systems that we're looking at showing the many different programs that people made in like a large programming class or that people independently wrote out in the wild, right? I was able to render them by showing their similarities and differences all together to say, hey, here's actually this design space that has been populated by people semi-independently. Maybe that can help you figure out what in your context is the right choice, given that we've populated the choices that other people have made. Similarly, we have some really cool work coming up with novel ways to express that intent back to the computer and ways to reflect what the computer is doing back to you, so you can be in a better position to form, revise, or refine your mental model of any data that you're working with, the system that you're interacting with, the world in which your system is interacting in, and what you want to do about it. So, right, so let's focus on these objective errors, contextually inappropriate choices, and subjectively wrong options that systems might be giving for us. So I'm going to start with an example from a search query that I did a little while ago, just to show you how pervasive this problem is with our existing interfaces that we use all day. Okay, so I was inspired by a particular situation to Google fraternal twins probability with maternal age, right? And that's an ambiguous request in Google for sure. But And the common ground, it's not really appropriate to put this necessarily in the common ground because maybe this should actually be here behind because you can't, you can reflect some of that, all of the internet into the common ground, and that would be an interface design question, but for the most part, we don't know exactly how to do that yet. So the first thing that shows up now in Google's search interface is an example of an experimental generative AI response that says right here, according to Baby Center, the chances of having fraternal twins are 6.9% for women aged 35 to 37, 6.8 for 38 to 40, 5.1, 41 to 42, and 5.9. I mean, I don't know about you, but that sounds pretty high. I'd be meeting a lot more twins if that were the case. Okay, but I know I have this mental model of the world that says older women are more likely to have twins. So I kind of subconsciously just kind of accept that's not incongruent with my prior beliefs. I scroll a little farther down the page, and I feel like I'm getting almost an independent opinion. Google has this other feature called People Also Ask, which finds natural language queries that are seem related enough to your non-grammatical search string. And this has very similar numbers. Formatted differently, it feels like an independent voice. Turns out they're actually the exact same numbers. And you may not notice, but actually same underlying website. So you could, at this point, kind of, if you were not thinking too hard, just immediately kind of walk away and be like, yeah, it's surprisingly high. But it turns out that not only is it from this source page higher for women younger than 35, which if that point had not been omitted, would have broken kind of this looks good to me, low cognitive engagement acceptance, but it also points out that actually this is for people using IVF, where they intentionally implant multiple embryos. And this has nothing to do with the original unspoken part of my request, which was, as people age, do people naturally have twins more frequently? There is no information sent about the fact that it, basically this is a crime of omission, so to speak, right? And so, obviously, like, most of the time this works, but I'm not satisfied with most of the time. I want systems, I want the user to be, wherever possible, completely resilient to these choices the AI is making that sometimes are, in this case, objectively wrong, right? Or you could say, maybe you could call this contextually inappropriate because I wasn't so clear that my query was about natural as opposed to reproductive technology, but it required me to, without information sent, I guess the only information sent was that there was a link, and that I felt like clicking it. Okay, so yeah, so this is an example of things being hard to notice because the context to evaluate the AI choice was hidden with no information. Okay, so let's look at another example. Here, this is a, some random Word document, and maybe your intent would be to summarize this case. And I use this example because I was at a conference held, like an AI and law conference at the law school, and a company was excitedly declaring that they were about to deploy AI-generated summaries to replace paralegal summaries for justices in a U.S. state. And I was terrified because I knew, right, that that the AI, no matter how well you fine-trained it, right, it may or may not call out, it may omit information that that particular judge in that particular precinct would find extraordinarily, like a mediating factor, say for sentencing, something like that. So this is, high stakes, right? The common ground here would be anything, I guess, again, how much of this can actually enter into the common ground of a human depends on how well you are able to design this to be consumable. If you can't, then it lives only in the kind of knowledge of the system. But for a summary of this case, it's really hard to judge that AI summary because the context for the summary is available, right? you are summarizing a particular document and you could read that entire document, but it's onerous to consume and also requires a great deal of memory, right? So in order to remember what was and wasn't included in the summary as you were reading it, it's just a little nerve-wracking. And then the final example is more of something where maybe there's a subjectively wrong issue, where instead of there being some sort of set of documents, the system has been trained on some large portion of the internet, and you're just interested in producing text that reflects your own intent, right? You might say, write me an email that requests a letter of recommendation from my professor last year. And actually, the example I'm thinking of is one where I wanted to write a colleague who had offered to cat sit a couple months ago, and I was like, hey, I'm having trouble writing this. Could you write me an email to my colleague about cat sitting? And it generated a 5-paragraph essay to my busy colleague within the close. So anyway, it's subjectively wrong. There's something objectively wrong with this. So I think that what I'm really excited about, and I hope other people are excited about, is this notion of AI resilience. And the first place where we've talked about it in some detail is in this conditionally accepted paper, led by Ziwei Gu and assisted by Ian Arajo, Kenneth Lee, Jonathan Kummerfeld, and myself, where we're looking at, specifically in the context of document summarization, what is an AI resilient summary to a document that allows you to, if possible, always notice, right? That you always have the context necessary and that you notice it to accurately judge whether or not some detail is that may or may not have been included in a kind of separate AI generated summary is relevant or not for your context, the questions you were asking as you read it, the purpose for which you were reading it. So you can think of this in the language of Don Norman as Gulf of evaluation on steroids, right? So it's not to say that this isn't included in the Gulf of evaluation, but I'm separating it out and trying to think about each one really, really carefully. Like I said, precursors to efficient recovery affordance guidelines. Okay, so one thing, so this question, the question posed by this paper started off with thinking about just one way in which a summary of a document could be contextually inappropriate, which is that it might be at the wrong level of granularity. And so to combat this, we started off, let's just imagine our document is one sentence, but obviously this is not limited to a sentence at a time. And we do a recursive sentence compression, right? We say, preserve as much, this is a large language model doing it, because it was too hard to do it in like a classic NLP way. Preserve as much of the semantics of this sentence as possible, but only by, but make it shorter only by removing words. And maintain grammaticality, right? You can't remove words that break the grammar of the sentence. So you do that once, and then you do it again on the, recursive sentence compression. And eventually, this is only 2 levels. You can go arbitrarily deep until at some point there's literally no more words you can remove and maintain the grammaticality or be within the similar enough as estimated by a large language model, which may or may not reflect the semantics that care about what's close enough. And then, so for this initial approach, right, you now can, the student Ziwei constructed a scroll bar, and you could just kind of say, I want a shorter summary, I want a longer summary. So now you have some user autonomy over what the level, at the level of the entire document, or maybe even just the paragraph, how much detail you have access to. The problem with this is that it still is not quite as AI resilient as I would like. It's still hard to notice the context to evaluate AI choices that are hidden. Again, with no information sent. If you're only looking at this, there's no information sent about what was cut, what you would find if you opened it up to back all the way to the uncompressed version. Right, so unless you open, and the memory associated to choose the best level of granularity is still kind of at the level of the document. This is nice, but it's not quite there. So we decided to do something else. Well, we instead tried to get rid of the interaction and say, let's not hide anything, right? Because hiding means no noticing, or it means luck in noticing, right? Luck that the user hovers over that object, luck that the user scrolls that far, and even when they expose that information, they cognitively engage enough to notice what's on the screen. So here, if you were doing this recursive sentence compression, the first thing to be cut here at present and well known, that gets the lightest color. Still legible. We're never going to make that illegible because that would, again, hide. But lightest color. And then in the next, right now, the next thing to be cut was in the atmosphere and the combustion of. So that gets a slightly less dark. And the things that are part of the grammatical core that are never gone, those will always be at the full saliency. And the result is you don't need any interaction to have the multiple levels all present at the same time. It's redefined by still legible gradations of gray. And now you could argue, well, I can't tell the difference between different gradations of gray. And I'd say it doesn't really matter, actually. Like, the whole point is that you can read a passage and continuously move between levels of granularity and accept or just continue reading, ignoring the de-emphasis for anything where, given your context that the AI does not have full access to, it's very important that you consider, right? So this is what it looks like for a GRE reading comprehension question. Those were how we evaluate these things because they had right answers. They were, the right challenge level for grad students that we could bring in, and we're roughly balanced in difficulty across multiple reading passages. So now it's funny, a colleague just pointed out to me, I was very proud, I sent this paper to him, I was like, look, isn't this awesome? He's like, GPT was probably, which is doing the reasoning that it was probably trained on those GRE reading passages. But he also correctly intuited that, yes, one thing you can do with this is you can start to give additional context, if you would like, to re-render this, right? Like, so because we're using large language model for that sentence compression, because it was better at doing it than like traditional NLP methods, you can also instruct it, like you can get more information from the user if they want to externalize. They can't externalize everything, but like, hey, I'm really interested in, ecology of rainforests. And you could have it re-render with prioritizing those details and being less likely to de-emphasize things having to do with what you stated you were most interested in. So this is just kind of like the de facto, if you did nothing, you just walked up to the rendering of any text. So we call this grammar preserving text salience modulation. The grammar preserving is what makes it work. We will compare it to a word frequency based text salience modulation, which is like the most basic thing you could do. And people actually did worse than normal. Like, just don't, right? Like, just keep it normal. But they did better when the core of the sentence was reflected in these in the darkest regions. So all AI choices are noticeable, and all necessary context is present in the view accessible to you to judge and ignore each choice without needing to do it. Bonus: the reader can continuously choose the best level of granularity. Okay, so here's I kind of flew. This is what I was. This is out of 4 questions about each reading passage on average. So we were looking at these tasks took between 8 and 10 minutes, but this word frequency text salience modulation, which basically represents the best thing that was available prior to this in literature. People take longer and do more poorly on these questions, and with GPT-SM, they do better on the questions and they take less time, which I mean is like something that I was a little I'm almost nervous to present it. I was nervous when you get a result like that. It's like you don't get anything for free, right? But I do think that the challenge of getting it to preserve the grammar is why we can, and we've done have some eye tracking studies of this after the fact, that like we can actually watch people saccade and tell ourselves qualitative stories based on observing their eye movements that I think make this believable. So I wouldn't be showing this to you because I want to be conservative about claims that I make if I wasn't pretty sure that this is a lasting effect, or at least certainly it taking less time. The idea that they will actually answer them better in less time, that I think in the initial results may, depending on the context, not be as reproducible. Yeah.
What about if you hide those texts, just showing the ones that you preserved instead of like showing them in a noticeable color, but just hide.
Yeah, right. So that was the first version, the interactive version, where you could scroll, hiding or exposing these more gray, or the other parts. So I don't remember if we had scrolling with gray or just scrolling with, but the difference between getting the interaction right so that you could even notice what was being hid or not between those levels is not trivial. We never really got that right. And the time and effort to decide while you're reading whether or not you want more detail, and also you don't know what additional detail it will give you, it just adds, it's what people do worse, right? And that study is the first study in the paper. So if you want to read more about how that went down, that was, so Z-Way, this was, it started as Z-Way's final project in our group. And so we came up with the interactive version, and then we kind of converged on the static version as being monotonically better. So like from normal text, just normal salience, approximately statistically significantly faster by about a minute out of 10, and about 10% more accurate in terms of accuracy. So if you ask them what their subjective experience was, almost everyone said that grammar preserving text salience modulation was most helpful. The second most helpful was the control, and people really didn't like that word frequency text salience modulation. We have some illustrative quotes here. B2 said, my reading became faster and less congested using GPTSM because I could easily skip over and ignore words that would grayed out if I simply wanted to get the main idea of the passage. Right? So this is where their reading goals are shaping how they interact with the static. P1 commented on how easy it was for the structural logic of the passage to be absorbed through GPTSM's multiple level visualization. So we did one final study. This was a really fun paper because we have the interactive version, a study of it. And then we do the study of the static version. And then we do, just to confirm that we are, being appropriate with our claims here, we did a follow-on component to that second study where we basically did GPTSM, but we removed the constraint of grammaticality, right? Could we factor that out and see if that's part of what's really making this work? 15 out of 18 participants perceived a difference. Some could not specify why, but of the 15 who perceived the difference, all of them preferred grammar preserving. P17 said, actually didn't feel that much of a difference. He or she was part of the 3 that couldn't tell the difference, but it seemed to have an easier time reading. It was just, kind of a felt experience. P13, who did perceive a difference, said, I like GPTSM better. It just makes more sense to me. When I skipped the great parts, I still understood everything. This speaks to, some of the participants spoke to intelligibility, right? Like when AI is doing stuff for you and you don't understand why. I'm not claiming, like AI resilience is not about intelligibility of what the system is doing necessarily. And that's a good thing to have as well, but that's not the point of this term as I'm trying to define it right now. It's just having the ability to notice and judge. That's it. So P13 also, oops, yeah. Okay, so I think we made our first AI resilient interface, an interface that helps people be resilient to AI choices that are not right for them. But it's only for document summarization. So just gonna pause for a second. I'm so thrilled. I just don't know if it's going to generalize because this feels a little bit domain specific, right? I don't know how I will. This will be stuck in document summary land. One hit wonder, So I'm going to move on to a slightly more a different domain in which we can think about AI resilience, where variation comes into play. And this work was led by Katie Giro, postdoc in my lab, who's now on the faculty job market. She's amazing. GPTSM was about making sure that there was information in the common ground visible to you at all times to help you contextually judge the AI's choices of de-emphasizing or not certain text. Okay, but what if you are in the domain or a situation like you're trying to write AI-assisted writing, right? Where it's not a particular document that you're reading or summarizing, but rather the entirety of the internet. We can't render the entirety of the internet and how that informs the particular statistical probabilistic next raw token, okay? But we can at least start doing multiple draws from the system and using the variation that we render back to the user to help them recognize some subset of choices that the AI is making that they can reflect on, right? Basically, it's like Stephen Dow's work. If you guys are familiar with his parallel prototyping work, right? It's like if you showed someone a poster that had 2 different fonts for the title and everything else was the same and asked for feedback, almost no one, it wasn't cognitively salient to them to think of, well, actually, like, this box is kind of awkward, right? I mean, unless it was like really, really awkward. But mostly people attend to alignable differences. They are, according to Gendner, who worked on analogical learning theory, they're either in draw us in that we are biologically designed to look at the alignable differences, like as an evolutionary thing, like, hey, there's 2 mushrooms, which one's poisonous, right? Or it's just easier to compute similarities or differences between structurally mappable objects just because they have correspondences, right? They have analogous components to be compared. It's easier to compare 2 mugs than a mug to an alligator, as counterintuitive as that is, because a mug and an alligator have more differences, right, in some sort of grand sense. So that's gonna be our strategy for building an AI resistance for an interface for reasoning about large language models. And this paper is led by Katie Elena Gero, assisted by Chelsea Swoops, Ziwei, Jonathan Kuhlfeld again, and myself, supporting sense making of large language model outputs at scale. So she made use of her extensive, she's also a professional writer. She thinks deeply about writing. She's a co-author of a paper that I think other folks in this room are co-authors on AI-assisted writing. And she really brought a lot of that expertise to this work, which I'm so grateful for. She did a formative study because I was like, hey, how many varying outputs of a large language model can we surface so that people can be aware of the many different choices it's making on our behalf as reified by these contrasting output examples. And I think sometimes only I am fascinated by doing that. And so it was nice that we also did a formative study to verify that this was actually something other people wanted and needed. So we did, she did 8 semi-structured interviews, 2 doctors, 1 researcher, 3 separate startup founders or CTOs that were putting out already large language model based public facing products, right? Which they would often maybe they would fine tune it and be like, is it better? Is it worse? Should we upgrade to GPT-4? They had questions, right? And they did not have a lot of tools to answer those questions. They also had 2 artist researchers who were interrogating chatbots, and kind of how they talked about sensitive issues, things like that. So what they found, or what Katie found, was that all of them found that automatic evaluations could not predict success on a task, right? There's just and automatic evaluation is, in a certain sense, I'm going to borrow Tamara Munzner's language on this. You should all read Iceberg Sensemaking. It's a paper she has on the archive. I don't know what conference will eventually publish it, but it's a beautiful paper, which argues, that there's so many layers of interpretation that we bring to data, and this interpretivist way of approaching data, where you're looking at the data and questioning what beliefs you have coming to it, what beliefs shaped the formation of that data, and basically just, she would say that it's not possible to do automatic evaluations, but regardless, automatic evaluations do exist, and the people out there recognize they don't work. So independent confirmation there. All interviewees engaged in some kind of manual inspection from a handful to 1,000 outputs. A particularly memorable description was one of the CTOs or founders described how when they would consider releasing a new version of the system, either some different parameter of the existing system or swapping out a whole new model, they would kind of lock some folks in a conference room for several days for them to go through, 1,000 outputs in response to various questions, because they were trying to basically do manual quality control on a probabilistic model that they could not, they had no guarantees of its behavior. So they were just looking at, statistically speaking, how can we form the best mental model we can of the system as it behaves so that we can feel more comfortable releasing it. So let's do more reinference or more regenerates and render them all back and see what that gets us. So, right, okay, so now this is a little bit of a, this is a bit of an abstract illustration, but see if it makes sense. So basically when you get a single, when you get a single response from a system back that is really complex and making many different complicated traces, and there's many dimensions in which, say, if I'm writing an email or I'm writing a creative story, there's so many different dimensions that I could go in. That intent space is very large. If I get one response back, it's like one dot in a pointillist painting, right? And if I get, hey, like I got 3 responses back instead. I think Bard for a while was like one of the only large language models that was by default producing 3 instead of 1. Okay, so now you have a couple, dimensions of variation becoming salient potentially in the contrast between the analogical contrast between these examples. But I want to see the whole painting, like I want to see the entire space of things that I could write, and so that I can better form or revise or refine my intent, given what I understand now with the data system world, to better re-express it to the computer, or to say, I'm done with the computer now. I can go off and write the best email because I understand what I want, because I was able to recognize rather than recall the right tone for the right points to talk about. So now obviously points of color in a pointillist painting and actual text, very, very different, does not scale. So we're going to provide some cognitive support. We are first going to we have this novel algorithm called positional diction clustering, which the way of finding analogical sentences in these, they have a similar position and similar diction. And so we can highlight in different colors these kind of common variations on a theme. And variation theory suggests that highlighting these analogical sentences should help users develop a mental model of the high-level composition, the high-level composition space that these are being populated by the LLM. And also because this is built on ChainForge, how many people are familiar with ChainForge? Okay, a couple of people. Because this is built on top of ChainForge and will hopefully with undergrads help be integrated into ChainForge shortly. We also have the functionality to look at these patterns as a function of the model that you're choosing, whether it's a fine-tuned model, a entirely different model, as well as like variations of the prompt choice. So this is what it looks like. Now, I think this goes down a ways. This is for GPT-4 versus GPT-3. You can't see that because of the zoom in the way. We call this grid positional diction clustering, but we also have a view where we say, all right, collate, so to speak. And now this is for a prompt about how to study for finals. And so you can see that this is actually one big cluster that is very similar starts over, I think, 50 different. The color here is a little difficult to see. Is the from one model, GPT 3.5 versus 4. But for now, I'm just kind of interested in the space. We are the adjacent things that are directly below and identical are grayed out to try and again just help you recognize the commonalities and variation across these different analogical statements. And then some things are just have no analogy elsewhere, and they might be lost in the text, the wall of text, but they are very easy to see. And each one of these individual points, they may or may not open up and help you discern or remember a dimension of variation that would otherwise have been not cognitively salient at the time. So, for each one of these kind of, you can think of this as what you're going to review is a dimension of variation, right? It could be class notes, textbooks, and lecture recordings, or it could be practice exams, right? Neither is like strictly true or not. It's just providing, to quote one of our case study interviewees, it's like a shopping cart model in a certain sense. You can very quickly bricolage or come up with your own based on what you see. So these grouping of analogous sentences with BDC and graying out commonalities enables skimming of analogical contrasts and hard to spot outliers. It hopefully helps people bricolage on their own answer, which is that intent refinement. But we also hope that this helps them develop a mental model of concrete textual distinctions between models and prompts. Whereas the previous view, grid PDC, is more like a high level, like mostly it starts with a greeting, and then it talks about this point, and then it may or may not talk about that point. Again, because it's actually an open question, it's a little weird. We went back to the late 1990s papers on analogical reasoning, and they were trying to suss out whether or not people were drawn in to these contrasts, or if they just found them easier. And I need to talk to Gettner about this because I don't know that what they're saying lines up with how I interpret the study. So I'm just going to leave that open. I'm just going to say invites rather than saying anything stronger there. So we also provided, just as kind of a control condition, something, exact matches, right? So highlighting things across the population of responses that were the exact same substrings in case that was helpful, and also unique words for some definition of unique. These were all just kind of baseline things that if a reviewer was just like, well, you could have just gotten this with unique words. Why did you need to do something so fancy? This was us trying to figure out because not only did we want to satisfy reviewer 2 in advance, we also wanted to make sure that we were not getting too enamored with our own novel kind of theory-based intervention and overlooking the value that some of these similar interventions might also provide. And maybe they should, always, we should know what they're good for and preserve them in any system implementations. So the results of our study here, we had a controlled user study with 24 people. We did some, and this just gives you a sense of what we were trying to draw out. It was a difficult study to run because I think that this is like a meta level point for just like people who are in this room who are running user studies. We have just we keep moving towards the part that we're asking people to do cognitively difficult enough things that money is not sufficient. They have to have some skin in the game. If they don't care, like programming, right? Like you're programming with with Microsoft Copilot. We found the behavior of people. This is Priyan's late-breaking work from 2022. People's cognitive engagement was so low with AI-generated, Copilot programs that they would either finish really fast, right, compared to the people who had no assistance, or not finish at all because they had accepted thoughtlessly all of these suggestions that turned out to not quite get them across the finish line, and now they were debugging code they didn't understand, right? So, but once you had people, this follow-up work that unfortunately was rejected because, they were like, well, this is an old version of Copilot. It's like, yeah, it's a contextual inquiry about how people used Copilot a year ago. But anyway, so in the contextual inquiry, which we should just put up on archive so I can point to it, basically found that once people actually cared about the code, oh yeah, they would cognitively engage. And then any results from that, you can say, hey, this is the cognitive engagement people are trying to do. How can we better support that? So likewise, we had a difficult time getting controlled user study results for things that people were just, didn't inherently care about. And that's why we also did a case study. So doing case studies, contextual inquiries and case studies are now like yes, controlled studies, great, we'll do one, but that's not where the real validation lies. So we're trying to help people notice and judge. Here, Grid PDC was the most used and most highly preferred feature. Participants found that Grid PDC helped them read responses faster. This was particularly true when we asked them to compare models using this infrastructure. So P1 said, if I saw some sentence highlighted, then I didn't read the sentence completely. I knew I already heard that before. P5 said in the baseline, I had to actually segment everything in my head after reading it. And when they say exploratory, they mean having access to any of those features. I didn't have to spend much time reading because the segmentation was already performed. So that's that pre-computation of similarities and differences that are helping people actually compare models that are probabilistic and are outputting in this very, very large output space. Interleaved PDC was the second most preferred choice along with exact matches. Interleaved PDC was mainly helpful in detecting content differences between, so this is like the lower level syntax differences. So P1 said there were certain clusters and singletons which were only present in one of the models, it was easier to see. And P15 said it would help me find out that there's some major difference in the distribution of outputs between the two models, right? Because they're like in different places in the interleaved PDC. All participants reported that having those features made the task of model comparison easier because it made it easier. We were pre-computing similarities and differences, and you can see which so everyone's kind of yes, give me the features. Linear was just kind of like the status quo way in which you might current interfaces look at the outputs of two models. And surprisingly, look, people are still, almost all of my interfaces run the danger of being perceived initially as very overwhelming because I'm trying to show so much, right? But I guess what I'm trying to say is that if you give people the support to see the latent dimensions of variation that are carved out, that whole painting, once they can see the whole painting, I think there's a reversal of that, kind of there's like overwhelm, but then there's you're supporting a form of sense making of conceptual modeling, right? Variation theory, which drives a lot of these design choices, argues that like seeing that greater variation, even if it's a little initially discomforting, will get you faster to a more accurate mental model of the process that is generating or reflected in that data. So for the 8 case studies in this case, we had creative writing folks, we had 2 folks who were doing model auditing, creative writing, a journalist, academic writing, someone from law. P7 looked at ways 2 trademarks might get confused and used grid PDC not to skim over semantic variation, but syntactic variation, and found that the use of different adjectives could make a big difference when adjudicating trademark confusion. Right? So these are like the low-level things that you could never anticipate in designing a benchmark. Automatic evaluation again. I mean, maybe you could author some sort of automatic evaluation on the fly, kind of program synthesis by example, or 2-shot learning style. But you need to be able to see the data, right? And this is an example of that. To ask and answer questions that matter to their context. P5. We prompted the model to rewrite an outline to be more clear and concise, talked about the shopping cart, which I mentioned, right? So picking the best rewriter of a great rewriting sentence. So I would argue that even if we can't see all the text that these large language models have been trained on, the people who are using these interfaces, right, these ways of viewing, and that leverage the variation across multiple generations, are more able to notice choices the AI is making because there are alternatives, and they can judge any given alternative within a context that is of the other possible outputs. So it's not as beautiful an example. It's not like complete AI resilience, which I would argue that the ground preserving text resilience modulation was close to achieving, but I think it's a step in the right direction. So I think that this value of variation comes in the contrast between analogical options that help people discern the latent dimensions of variation, helps them notice a mental model, judge those choices, and also potentially recognize what they want. And so I guess the final system, unfortunately, I given the time, I kind of anticipated I wouldn't have that much time to talk about G4JI. But this was a project led by Ian and assisted by Chelsea Swoops, Brian, Martin Wattenberg, Professor of Visualization, and myself. And this is really Ian's brainchild. And what I just want to point out here is that Chainforge was the infrastructure on which we built the features for looking, right? It generated the variation. It did not necessarily provide a lot of support beyond just showing things in grids, which is already a lot of support, actually, for comparing the outputs of various models, right? So even just that was extraordinarily useful, right? The features we built were on top of that. We're hoping to merge them in. They're not competitors there. But what's beautiful about ChainForge is that it has a templating language by which you can construct variations on prompts, in addition to testing multiple models at once. And so basically these templates in the language of variation theory are allowing you to, as the user, define dimensions of variation that you absolutely know you care about, right? And so you don't have to just be responsive to whatever dimensions kind of bubble out of the variation that the large language model with its own biases and kind of directions will go. And so that kind of adds a really nice additional aspect of variation, controllable variation, to our space. So I'm gonna stop there. I'm going to thank the poor Zoom thing is covering their faces, but Ziwei, Gu, Katie Giro, Ian Arajo, Chelsea Swoops, Priyan, Biathan, Kenneth Lee, Martin Wattenberg, and Jonathan Kummerfeld. They have been just deeply in the. It's just been such a joy to work with them for the last like 9 months to a year, trying to figure out how all these things are interweaved and how they can, how we can use variation to help people be more resilient to AI choices that aren't right for them. So I hope you find these, they're available in archive. There's lots more details there. And I hope you find this concept of AI resiliency exciting. And if you see any situations where you think you could make it more AI resilient, maybe do so and let me know, or tell me about it. I want to see how far this concept can generalize either as a challenge, or maybe there's even systems out there that are particularly good examples doing it already. So with that, I'll take your questions.
Again, I can speak again. Oh, it's really nice. I also want to congratulate on 3 or 4 Kai papers, I think, in that space. That's an amazing accomplishment. So we'll do questions over Zoom and in the room. I think Anhong is already waiting, so let's start with that.
Yeah, thanks for the great talk. I think one takeaway I have is from the illustration you showed, the painting, and maybe combining study 1 and study 2 is I show the painting, but I show some in grayscale, some in full color, and to help the user quickly skim and perceive information. And it seems like by leveraging variation theory, you can present 10x the data, but only requiring 1.5x the cognitive load, and the user may still want to do that. So I think that's a really interesting idea. But I'm wondering how generalizable do you think this is to other modalities beyond visualization? So for example, what if it's a blind user using screen reader? How would you use audio interface or other modalities that can leverage this?
That is an excellent, excellent question. And this is such a new concept for me that I mean, just the example of the screen reader, right? I mean, you could literally reify text salience as audio, but I don't know that it would have the same AI resiliency as the rendering statically, right? Because I mean, I'm really taking advantage of the fact that human isocods are kind of like very jumpy and backtrack a lot, and there's like a lot of cognition as you're passing. It's not a linear process, whereas reading to someone is. And that said, I get the impression that people who use, say, a screen reader, I don't want to say they have highly developed abilities to take in information in that way. Like if you watch someone using a screen reader, often you can't make out what it's saying, but they've been using it for so long, they kind of adapted their neural, so I think it would be interesting to maybe even work with, better understand what superpowers they have, where we could map some of the non-linearity of reading to their experience of the audio. But regardless, everything would still be hearable, right? That if you hide something, you can't notice it. I'm just broken record. I keep saying that, but hiding is such I just feel like so much for so long, right? Like it's been like make it easier on the user, hide, simplify, right? And so I feel like I'm not saying that's never a good thing. I'm just saying that if an AI is making a choice, if you hide it, you can't recover. Or you're just going to be lucky if you notice and recover. And if you provide cognitive supports variation theory and analogical learning theory are what I'm drawing on to design those cognitive supports, but I'm sure they're not the only theories that have some design implications for how to help people cognitively engage with the additional information and context necessary to make those appropriate judgments.
Yeah, you can go.
Thanks for the great talk. I really like this framework, and I like how this extends the classic algorithm execution evaluation theories. So it sounds like the first two studies, it was intervening on the evaluation loop where users were provided some scaffolding to make sense of the AI generated content. And maybe Chainforge is more intervening on the input, like helping them to improve the intent and prompt. So I wonder what are your thoughts on when should we like focus on the input loop and when should we focus on output?
I think that's a false dichotomy. I mean, I guess right, we, when we have both variation here and variation here, think about, and again, this concept of common ground is really important here. If you meaningfully make the context part of the interface so that it is like visible and understandable as a tool for thought for both the computer and the human, then they can use that. They can clarify what they want on the examples in the common ground, right? They can't reach in and say, hey, that Trinity example you have, that's not a good one, right? But once it becomes externalized, you can say that is a bad example, or this is this particular thing that's wrong with this example, right? Don't generalize here. Reggae is an example from my time using program synthesis by example, where it's just you could augment examples with lightweight annotations of like, hey, this is an example of a number, any number, right? This is an example of a character, any character. That's hidden information in the example that I gave. It was in my head, but giving me a lightweight way, once that became part of the common ground between me and the computer, just be like, this is what I meant. It's just so much faster to communicate your intent. So this externalization better supports the intent expression. They work together. Yes.
So one place I think a AI resilient interface might have accidentally been developed is in recommendation algorithms, which when you think about it is kind of a summarization task, right? I go to Facebook, I don't actually want to see a linear list of every single post that anyone in the world has made. The algorithm is going to recommend to me in an ordered list. And things, if I scroll forever, I eventually will see every piece of content, right? Would you consider that to be an AI resilient interface? And if not, how could it be adapted
Right.
so it is?
Great question. So I think like the way you phrase the question is the way that I was originally phrasing the question as well. Is it AI resilient or not? Right. And I think that once you get beyond kind of like very, very narrow areas like document summarization, it's more, how can we make it more AI resilient? And so I would say that if you're getting a single list of things, right, based on some inference about what you care about, and also what Facebook cares about, then you, it's hard to come up with evidence for why, it's hard to overcome, notice and recover from choices that you don't like. So maybe, the most trivial thing to say would be like, oh, maybe there should be, multiple things, like multiple alternatives for each spot in your thing. And that's kind of a trivial extension. I don't know how, I have to think about, is there something more graceful, better? Another thing, could you imagine interleaved PDC on all of your, the top 100 posts? I don't know if that would be a pleasant reading experience, but at least you might be able to better recognize, hey, here's all the birthdays, okay, and here's all the marriage photos, right? Like in the top 100 posts, I'm not ordering them in the way that Facebook and/or the algorithm that Facebook constructed thinks is best for their bottom line. It's just the top 100 rendered in such a way such that the analogical relationships, I can very quickly take them in, and then I can focus on the parts that are interesting. Maybe that one post is about programming languages. Like, oh my God, someone's still listening about programming languages on Facebook. Fantastic. Maybe I'm the last student. I don't know, I left it a while ago. Anyway.
All right, so we will conclude. Thank you, Elena.